This is another high-low method example. So we are going to go through the same process where first we have to figure out our variable cost per unit. Then we can figure out our fixed costs. And then we have our formula. So it says here, express the company's maintenance costs as an equation where X represents the gallons of paint produced. All right, so I'm going to go ahead and type the generic formula here. Oops. Y equals A times BX, right? Does anybody remember how to state that in words?
Total cost equals total fixed cost plus variable cost per unit.
Perfect. The total cost equals the total fixed costs plus the variable cost per unit times the number of units. Excellent. Zach?
Should that asterisk be a plus sign?
Plus. Thank you. You're right. It is a plus sign. Yeah. All right. So what's the first thing we have to do here? We have to find the variable cost per unit. And what's the first step in doing that?
Finding
The highest month and lowest.
Highest month and the lowest month. All right. So what is our highest month here? November. Okay. And the lowest month? February. We didn't do this one already, did we?
We started it.
yeah.
We started it?
Started it.
Oh, but we didn't finish it? Okay, we might as well just go through the whole thing. Okay. Okay, so February, we have to take the difference in costs divided, oh, it's actually November and February, right? The difference in costs divided by the difference in activity. So the costs is under maintenance expenses. The highest month, Elvie said, was November. And the lowest month is February. Right? And we're going to divide that by the activity. The activity in November was 128,000 gallons. And in February, 68,000. Right? So then we can simplify this to actually get the difference. Well, you're going ahead of me, so hang in there. So it's a difference of $6,000 in cost, correct? And 60,000 in gallons, right? Okay. Well, then we actually do the division. We take the $6,000 divided by the 60,000 gallons. We get 10 cents per gallon. That is our variable cost per unit, right? Any questions on that? So that has to be done first. I'll put here for reference, that's our variable cost per unit. Okay. Now the next thing we have to do is what? We need to find out what our total fixed costs are, correct? And how do we do that? So we have to pick one of these months, and it doesn't matter, this was November, right? And this was February. We could use either month and we should come up with the same answer either way. In fact, maybe we'll do it both ways just to see. So what we're going to do is we're going to multiply the variable cost per unit times the number of units. That'll give us the total variable cost. Then we're going to subtract that from the total cost. The difference is our total fixed cost. Okay, so we'll take 10 cents per gallon times 128,000 gallons equals 12,800. Correct? We take that we take the total cost of 72,800 for November minus, we'll just put that this is our variable costs, our total variable cost. So we take our total cost minus our total variable cost. We just calculated, and that gives us a $60,000 total fixed cost. And just to double check, and so you see that I'm not making things up here, if we use February's data, we could do the same thing. We take the variable cost per unit times, how many gallons were there in February? 68,000 equals 6,800 total variable costs, right? Then we're going to do what? We take the total costs from February, subtract the total variable cost we just calculated, and what do we get? $60,000 total fixed costs. So again, it doesn't matter whether you use the high month or the low month. You should get the same answer, and you know your fixed costs. So what is our variable cost per gallon? 10 cents. What is our fixed costs? 60,000. And what is our maintenance costs formula? We'll start with total costs. Instead of calling it Y, I'll put TC for total costs equals what? 60,000 plus variable cost per unit times the number of units, right? So now we could use that to estimate different levels of production. 60,000 in fixed costs plus 10 cents times the number of units. Anything need clarification? We do have one of these in the problem set, so we'll come back to it one more time, but let's move on to part B here. Predict the maintenance costs if 90,000 gallons of paint are produced. Okay, so now we'll use this formula that we just made. If we produce 90,000 gallons of paint, are we going to have $60,000 of fixed costs? Yes. And what's our total variable cost going to be? 90,000 gallons of paint.
9,000.
Okay, $9,000, right? We take the number of units times 10 cents. Then we add that to the fixed costs, and so our answer is 69,000. For C, it's 81,000 gallons of paint.
$8,100.
68,100. Excellent. How'd you get that, Alec?
1,000 times 10 cents.
Okay. 81,000 times 10 cents plus the $60,000. And part D is actually already done for us. Here we can see this data plotted on a chart. This pretty much makes a straight line. You can see, like, here's sort of an outlier. That month was really different for some reason. But most of the other months are pretty close to the line. I think this came from a linear regression. Let me see. Using Excel, create a scatter graph. So this is from a scatter graph on Excel. So if we use the scatter graph method, this is what we would have come up with. And we would see that there is a pretty direct correlation. The more the dots are on the line, the better the correlation between number of units and total cost. All right, any questions on this exercise? By the way, while I'm thinking of it, sorry. Okay. Oh, we didn't do 10 yet, did we? So let's do 10. Looks like we have another high-low method. I forgot about this one. So basically, same thing here. Express the company's utility costs as an equation. Okay. So we know the basic equation is y equals a plus bx. But we will fill that in as we actually calculate the numbers. Here we have a whole year's worth of data. What's the first thing we have to do? Highest and lowest month, okay. And what's the highest month? November again, all right, 875. And what's the lowest month? April. Yeah, it looks like April with 470. Okay. All right, so that's, we have to start with the costs here. So the costs are 3,281 in November minus 1,823 in April, right? And then we divide that by the activity between the 2 months. Now we have to simplify that. $3,281 minus 1,823 is 1,458. Divide that by, looks like 405. There we go. All right, so 1,458, that's the difference in cost, divided by 405, the difference in production. We get 3.6, which means what? $3.60, right, is our variable cost per unit. Okay, questions? So what do we do next? Okay, we need to figure out the fixed costs, right? So how do we do that?
Variable cost per unit times the number of units.
Okay, so we take the 360 that we just calculated. We could do either the 875 or the 470. So let's just do the 875. That gives us a number of 3,150. And what do we do with that number? Subtract it, Zara, from the total cost. So we take the total cost in November of 3,281. Did I say 3,150? What was the number? Forgot. Okay, let's do it again. 360 times 875, 3,150. Okay, so 3,281 minus 3,150 is 131. So our fixed cost in this case, you can put it right here, is $131. Our variable cost per unit, $360. Okay. So we could say total cost equals $131 of fixed costs plus 360 times the number of units. All right, any questions? So B says predict the utility costs if 800 tables are produced. How do we do that? Use that magic formula that's right here, right? Where do we start? Okay, 800 units times 360 per unit. Then what? Plus the 131 fixed costs. So it looks like 3,011. And we can do that one more time for 600 tables for part C. 1,291. And then we check our answers. Well, that's the problem set. 3,011, 2,291. Perfect. Isn't that nice how in accounting, if you do things the right way, you get the exact right number? Isn't that nice? It's not like art. There's nothing wrong with art, but there is no right answer, right? Okay, and part D, again, it says using Excel, create a scatter graph. So this is already done for us. You can't get any more precise than that, right? That's a perfectly correlated relationship between the costs and number of units produced. All right, any questions on number 10? All right, 11 we've already done. Number 12 is kind of similar to 11, but let's go ahead and knock this one out. Again, they give us 2 months of copying. The first month had costs of $360 for 5,000 copies. Second month was $280 for 3,000 copies. We have to figure out the total variable costs. So we don't have to go through the whole process. We just have to figure out variable cost per unit and then multiply it by the number of units, and we're done with the exercise set. So again, how do we start when we're doing this kind of a high-low formula? The difference, okay? So we take the difference in costs, which is $80 between the 2 months, divided by the difference in production, which is 2,000 units, right? They must lease from the same company as exercise 11 because we get 4 cents per copy. Okay, that is our variable cost per unit, right? But in this question, it's asking for the total variable costs. So now what do we have to do? Multiply it by the number of units, right? And so our answer is $300. Right? Let's see where. Oh, you know what? Don't pay attention to that. I changed this one a little bit from the book for some reason. I don't know why, but at some point it made sense to change it. So this is the right answer. All right. So we're done with the exercise set. And I think we have only one problem left to do because Problems 1 through 3 are all just creating income statements. I think we did one of those, and the other two I'm sure you can handle. We did problems 4 and 5 today. And so all that's left is problem 6, which, guess what? It's another high-low method. You're going to be dreaming about the high-low method. Or having nightmares, right? Okay, so it's pretty much the same thing. A says prepare a scatter graph. That's already available for us. Looks pretty perfectly correlated, wouldn't you say? All right, B says using the high-low method, create the cost formula. All right, so we need a high month and a low month. Highest is April and lowest is May. Great, let's just go ahead and do our calculations right here. So April has 14,200 of shipping costs. May has 6,550, right? April had 8 yachts and May had 2. So then we simplify that. We get 7,650 over 6. Oops. And that equals 1,275. What do we call that 1,275? That's our variable cost per unit, right? Okay, and what's our next step? Okay, so got to find the total fixed costs. And how do we do that? Okay, exactly. This one's pretty simple, so let's just go ahead and do it both ways. Let's start with number 2. So we take our variable cost times 2, 2,550. We subtract that from 6,550, $4,000, right? And if we take 1,275 times 8, subtract that from 14,200, it's also 4,000. So whichever level of production, we get the same $4,000 in fixed costs. All right, so then we can say our shipping cost formula equals $4,000 of fixed costs plus 1,275, was it? Is that right? Times the number of units. It says here in C, the least squares regression method was used and the analysis resulted in this cost equation. Total cost equals 4,000 plus 1,275x. That's exactly what we came up with, right? So in this case, our high-low method gave us exactly the right answer. Again, the least squares regression method is the most accurate. So in some cases, our high-low method might not be exactly the same. But the high-low method provided the exact same answer as the least square regression analysis. Okay. D, we would estimate shipping 10 yachts to be what? How much would it cost? We have our variable cost per unit times 10 units plus fixed costs, 16,750. Commentary. Okay, what are we commenting on here? Comment on how accurately this is reflected by the scatter graph. Okay, so 10 yachts would be somewhere like up here, right? We have 7, 8, 9, 10 would be around here. And if we followed that line over, this diagonal line, it would take us around there, and that's probably around 16,750, right? Just eyeballing it, that appears to be very accurate. So we can say our estimate is consistent with the scatter graph. Sound good? And then the last part, what factors other than the number of yachts shipped do you think could affect Carolina yacht shipping expense? So even though we can make these predictions, there are things that could impact the costs that we can't predict, right? So this is just looking at the past and using the past to predict the future. But if something out of the norm happens in the future, that could throw things off, right? That could make our estimates wrong. So what kind of things could happen that would increase shipping costs beyond the number of ships we ship? What else could impact shipping costs? Natural disasters. What else?
Tariffs.
Tariffs. How about fuel prices? Right? We have an extreme change in fuel prices that could impact shipping costs. What was that?
Inflation.
Inflation? Yeah. Okay, so that's why we can't be 100% sure with our predictions. You can think of other examples, but I think that's a good start there. And explain. Well, you can just say there are, we can say our estimates are based on past or prior data, but some potential impacts not be fully anticipated. All right, what questions do y'all have? Anything need clarification? Yeah, Zay?
Are there going to be like modules in the future where we have to do the scatter?
No, we are going to be using spreadsheets, but we won't be doing charts or graphs or anything like that. Those are fun to do in Excel, but not, there's another class here, Excel Analytics. I think it's 150.25, where you can do a deep dive into Excel. All right. Have a good rest of the week, everybody. See you next week.